Now, knowing that, we can now do part B. Part B says calculate the energy of activation in joules over moles. So remember, the energy of activation is EA. To solve this question, we're just going to say EA is involved here. It's negative EA over R. We're going to say that this fraction, in a sense, is also the same thing as the slope, as M. So they're both the same exact thing. They're both equal to each other. Okay. Remember, M is your slope. And what's your slope? Your slope is the change in Y over the change in X. And if we take a look here at this graph, we have 1 point here and 1 point here. Here, this first point up here, X is equal to 0, Y is equal to 0.569. In this second point here, X, which we're going to say X2 is equal to 0.0047, where Y2 is equal to 0. So, slope is equal to Y2 minus Y1 over X2 minus X1. Let's just plug in what we know. So Y2 is 0, Y1 is 0.569. X2 is equal to 0.0047. X1 is equal to 0. When we work this out in our calculator, it's going to give you back negative 121.064. So that's what our slope is equal to. And remember, R here has a constant value. This is our constant when it comes to energy. And remember, we said that this number would be 8.314 joules over moles times K. So that's what R is equal to when we're dealing with energy. So we have all variables known except for activation energy. So all we have to do now is just solve for it. So multiply both sides by 8.314. So negative EA equals negative 1006.52 joules over moles. And we know it's in joules over moles because R had joules over moles. Then we're going to divide out the negative because we don't want negative EA, we just want EA, activation energy. So then we're going to say activation energy then becomes positive 1006.52 joules over moles. Don't worry, these two questions were a bit of a challenge. I did that intentionally, just to show you how we can manipulate the Arrhenius equation towards a potential graph. Even though you may not see something like this in lecture, you most definitely would see some variation of it in lab. So it's always good to remember the techniques we've used here. Now that we've done this one, I want you guys to attempt to do the practice one left on the bottom of the page. What you should realize here is, I'm asking us to calculate the rate constant. So basically, before we can do that, we have to figure out what is the order of our reaction. Now I give us 3 graphs. Only one of them gives you a linear line, a straight line. The one with the straight line gives you the identity of the reaction. It gives you if it's first order, 0th order, or second order. Since this is the only one giving us a straight line, from this plot of Y versus X, you should tell me what the order of the reaction is. And from that, you need to know which integrated rate law to use. And from that, you can solve for your rate constant K. So first tell me what's the order of the reaction based on this graph with the straight line. And then from that information, you can find out what K is. So good luck, guys.